Flexi Arch Bridge System. Arches are strong, robust and look good, but they are labor-intensive and expensive because they need formwork in order to center the bridge and strong abutments to transfer the loads. Flexi arch bridges are a modern way of constructing arch masonry bridges without the need for centering, internal steel supports or mortar as required by older, traditional arched bridges. This new and innovative system of constructing arch bridges was developed and patented by Queen's University Belfast School of Civil Engineering and McReef. The Flexi Arch Bridge system uses precast concrete sections to dramatically improve installation time. Flexi Arch Bridge systems use much the same principles as a traditional stone masonry bridges, but they are made using modern precast concrete methods. Individual precast concrete tapered blocks are connected by a polymeric flexible membrane which does not require any mortar. The arch falls into shape when craned into position and is self-supporting by virtue of its own weight. The use of the membrane instead of traditional mortar helps to prevent internal corrosion, rebar expansion, and concrete cracking or spalling. Once the foundations have been built, the arch is lifted in, spandrel walls attached and concrete fill poured. The road surface and cladding can then be finished. Typical build times for a 15-meter arch are less than a day. The maximum span is limited by transport and crane lifting capacity, but they are already developing a double radius arch for rail profiles. Bridge Girder Erection Machine. Have you ever wondered how people can assemble extremely large and heavy concrete overpass girders? Previously, people had to use traditional cranes. However, currently, construction companies have specialized overpass girder assembly machines, such as the SLJ 900 Bridge Girder Erection Machine in this video. SLJ 900 Bridge Girder Erection Machine is an overpass girder assembly machine manufactured by Beijing Wao Joint Machinery Company with a length of up to 9.8 meters and a weight of 580 tons. The SLJ 900's mission is to move extremely large concrete overpass girders. Not only does it take up a lot of space at the construction site, the overpass girder is also very difficult to move because it is too bulky and heavy. Instead of lifting from the ground onto the overpass piers, the SLJ 900 Bridge Girder Erection Machine will take the concrete beams along. Then, the concrete beam will be slowly dropped onto the overpass shaft. This process is faster and more accurate than the traditional crane method. Construction of bridges using beam launcher. Advantages of bridge construction using beam launchers. Speed and efficiency. The primary advantage of using beam launchers in bridge construction is the remarkable speed and efficiency they offer. Beam launchers are gantry-like structures equipped with specialized equipment for lifting and placing bridge beams. They allow for the simultaneous construction of multiple spans, reducing the overall construction time significantly. This expedited construction process is particularly advantageous when building bridges on heavily trafficked routes or in emergency situations, where minimizing road closures is of utmost importance. Reduce disruption. Beam launchers contribute to reduce disruption to traffic during construction. Unlike traditional methods that often require road closures or detours, beam launchers enable construction to progress over existing roadways with minimal disturbance. This feature is especially beneficial in urban areas, where traffic congestion can have a substantial impact on local economies and daily life. Enhanced safety. Safety is paramount in any construction project, and beam launchers offer notable improvements in this regard. The majority of beam launcher operations are conducted at an elevated and controlled location, reducing the risk to workers on the ground. Additionally, the use of standardized components in automated processes reduces the margin for error and the potential for accidents, resulting in a safer work environment. Cost-effectiveness. Bridge construction using beam launchers can be more cost-effective in the long run. The reduced construction time, labor requirements, and lowered maintenance costs due to the use of precast concrete components all contribute to cost savings. Furthermore, the minimized traffic disruptions can indirectly lead to economic benefits for local businesses by avoiding traffic-related losses during construction. Sustainability. The use of beam launchers aligns with sustainable construction practices. Precast concrete beams, often used in beam launcher projects, can be manufactured with environmentally friendly materials and processes. Furthermore, the accelerated construction timeline minimizes the overall environmental impact of the project, including reduced emissions from construction equipment and shorter-term disturbances to local ecosystems. Quality and precision. Beam launchers are equipped with advanced technology and automated systems that ensure the precise placement of bridge beams. This results in consistently high-quality construction, reducing the need for costly repairs and maintenance in the future. Additionally, beam launchers are adaptable to various bridge designs and configurations, enhancing their versatility. The construction of bridges using beam launchers represents a significant advancement in civil engineering. The advantages of speed, efficiency, reduced disruption, safety, cost-effectiveness, sustainability, and high-quality construction make beam launchers an attractive option for modern bridge projects. As the world continues to prioritize infrastructure development, beam launchers are poised to play a crucial role in building safer, more efficient, and environmentally conscious bridges that connect communities and drive economic growth.